The magnitude system is used by astronomers to measure the brightness of objects such as stars. It is kind of odd from our modern sensibility, but that's because it was set up in 129 BC by Hipparchus of Nicaea. It is convenient for estimating the brightness of astronomical objects such as stars. In the mid-1800s, the British astronomer Norman Pogson conducted absolute brightness measurements of stars at the Madras Observatory in southern India. By correlating his measured brightnesses of known stars to their existing catalog magnitudes, he refined the magnitude system in such a way as to be backward compatible with existing naked eye and eyepiece catalogs. He found that our eyes see real brightness ratios as approximate differences in apparent brightnesses. So he defined the magnitude system such that 1. The star Vega is exactly zero magnitude regardless of how it is measured. 2. A difference of 5 magnitudes represents a ratio of 100 in brightness. Therefore, a 5th magnitude star is 100 times dimmer, or 1% as bright, as a 10th magnitude star. Therefore, a 5th magnitude star is 100 times dimmer than Vega. A 10th magnitude star is 10,000 times dimmer than Vega, and a 15th magnitude star is 1,000,000 times dimmer than Vega. Similarly, at its brightest, Venus is 100 times brighter than Vega, so it would have magnitude of -5. The Sun is so bright that it has a magnitude of -26.7. Mathematically, we can find the brightness ratio of any two objects by subtracting their magnitudes. If this difference is a factor of 5, we can solve it in our head, because it's simply a factor of 100. But if it is not, we need to use exponents. Therefore, the brightness ratio, B2 over B1, is given in terms of the corresponding magnitude difference, M2 minus M1, such that the ratio of the two real brightnesses, B2 divided by B1, equals the reciprocal of 100 to the difference divided by 2 power. And that's the same thing as saying it's 100 to the negative that difference, which is the same thing as reversing these two and making it positive if you wanted. For example, a magnitude 5 object is 10,000 times brighter than magnitude 15 objects because B of 5th magnitude divided by B 15th magnitude is equal to 1 divided by 100 to the 5 minus 15 divided by 5. That is equal to 100 to the negative 5 minus 15 divided by 5, which is equal to 100 to the 15 minus 5 divided by 5. 15 minus 5 is 10, so it's 10 divided by 5, which is 100 squared, which is 100 times 100, which is 10,000. Now, why do we go through all this effort for a magnitude difference of 10? We already know what the answer would be. But if the magnitude difference is not exactly 5 or 10 or 15, we would have to go through this whole mathematics to figure out what the brightness ratio is. As it turns out, since 100 is simply 10 squared, we can simplify the brightness ratio as B2 over B1 is 100 to the negative M2 minus M1, which is 10 squared to that. And remember, when you have something with an exponent to an exponent, you multiply the exponents. So 2 times this by 5 would be written as negative 2/5 times m2 minus m1. Now we can use the simplified version of the same problem we did above, and we get b fifth magnitude divided by b 15th magnitude is equal to 10 to the negative 2 fifths times 5 minus 15. 5 minus 15 is negative 10. Negative 2 fifths times negative 10 is 4. So it's 10 to the 4th, or 1 with 4 zeros after it, or 10,000. The same answers we got before. So as an example, consider the Sun, which is a magnitude of negative 26.7. How many times brighter is the Sun than Vega? Well, making the Sun star 2 and Vega star 1 in our equation up here, we have m2 minus m1 is negative 26.7 minus 0, or negative 26.7. Therefore, the brightness ratio is b of the Sun over b of Vega is 10 to the negative 2 fifths times negative 26.7, which is 10 to the 10.68, which is also 10 to the 10 plus 0.68, which is 10 to the 0.68 times 10 to the 10th. And so now we can turn this into scientific notation, where 10 to the 10th is this part of our scientific notation, and 10 to the 0.68 is just 4.8. So it's 4.8 times 10 to the 10th, which is 48 times 10 to the 9th, so it's 48 billion times more bright than Vega. Now you should be able to solve these problems where you're giving a difference in magnitude, and from that you need to find a ratio in brightness. Again, remember that magnitude is just a measure of the ratio of any object to that of Vega. And again, remember that astronomers use the magnitude system because it's backward compatible to a time of 129 BC, which means it's been in use for well over 2,000 years. Thank you very much for watching.